Again, I want to emphasize that it may not be easy to conceptualize or grasp exactly why classes are useful. What we're going to do instead is focus on the mechanics of creating classes, and then we're going to gradually begin to see how we might be able to put these different features together. So bear with me as we begin exploring the mechanics of classes, which begins with the class statement. Now, the class statement needs to be accompanied by a name, and so I'm naming my class. I'm going to name it my class because that's an arbitrary name, and I want you to understand that you can call your class whatever you'd like. If we fill our class statement, which as you can see is a block statement like if or else or def, if we fill it with some value, like let's say pass is just an empty value, right? An empty block. Empty statement for an empty block. If we do that, we can see that it's possible to create an object of the class, an instance of the class, simply by calling the class, even if the class doesn't define anything. We can still create a class of this type. And if I print X and I print the type of X, well, we're actually going to see very similar output. But in doing this, I hope it becomes clear that it's possible to create a new type of object simply by using the class statement and the name. Here you can see that when I print the object itself, it tells me that it's a myClass object. And if I check the type of it, I see that it's of class myClass. Now don't forget that when we create an int, it tells us it's type int, right? If I say x equals int 5, for example, and this is constructing a new int object, and I check the type of it, I'm going to call this y, and I check the type of it, it's going to tell me class int. Now, I wouldn't worry about this main part. This is related to the fact that we are defining this within the same file in which we're using it. So main refers to the current file, but the main idea is that it's a myClass object. So you can see that when I create an integer and then ask for the type of the integer, I see class int, and we're very familiar with that and with the other types that we've created. But the main point of this particular example is that we can create our own object types quite easily by using the class statement and a name. And once we've done that, even if the class is empty, even if the class doesn't define it to do anything, all we need to do is construct the object and we'll get back an object of that type. Again, it's important to emphasize that we're doing exactly what Python does when it gives us a new object, an int or a string. And in fact, if I use the standard form of constructing an int object, you see that I'm doing the same thing that I did with my class. The only difference is the capitalization of the class name. I am, in fact, taking the type of the object and calling it like a function. Same way we were able to do with the stir function or the list function in order to convert values to those types. Here we're creating a new int object, and it's of class or type int. And here we're creating a new myClass object, which is of class or type myClass. So again, all you need is the class statement and a name. What you choose to name the object is up to you. Usually it's going to relate to what the class does, but it can really be anything. It really does begin with a name because an object is really something that you are conceptualizing as being able to work with. We all understand the conceptualization of a list or the conceptualization of a file. And so my class is a little bit abstract, but bear with us, we're just looking at the mechanics. Later on, we'll start to think about objects that can actually do things for us. Now the next thing to discuss has to do with the functionality of an object. For example, I can create a string, right? And I'm using, by the way, I'm using the constructor form that is calling the function just to emphasize the similarity between the class that we just created and the built-ins that we know. You know that we can just say y equals hello, and that's just a shortcut. But we're going to work with the object, the class constructor, the function itself. We call it a constructor. You know that once we create an object like this, we can call methods on the object. And if we call methods on the object, we're going to get another object type of some sort. In this case, we're going to get back a new string. Or if we wanted to, let's say, call a different sort of function, like the count function, we might not get a string. We might get some other value. This is counting the number of L's in the string. So we understand how methods work. We understand that they provide functionality that's based around the data that we're working with. The upper method is based on the original string that we created, HELLO, and the count method as well works with that value. When we work with a class of our own design, we also have the opportunity to create methods. Now we'll be working with the data of my class a little bit later, but for right now, let's just look at how a method is created for a class. Let's use the greet method. The greet method prints a happy greeting. And if we'd like to use it, how do we call a method on an object, right? We say x.greet. Simple enough. So the second piece of functionality that we want to work with and understand is the method. The first is the class statement. And again, if you have the class statement and a name, you're able to create your own type. Doesn't matter what the type is or what it does. It doesn't matter whether it's a very practical or in this case just very general and a simple example. You can create a class. And then the second thing is the use of a method. Once you define this function, and you can see that this greet is a function that we defined inside the class. Once we define this function inside the class, we have now enabled this as a method such that we can take an object of the class, or what we call an instance, and I'm going to start to use that word more and more. This is an instance of a myClass object, just like we had instances of a string before. You can take that instance and call greet. You can call the method. In this case, we are calling the greet method, and we're seeing that that method gets called. Now again, don't attempt to put this together into something meaningful just yet. We're going to build a lattice of functionality, and then we'll start to see how it all comes together. Just understand that the class statement defines a new object type, and any functions defined within the class are methods that can be called from the object. We'll get into more detail on this in a moment. Before we do continue, though, I'd also like to point out that we can pass arguments to these methods as well if we wish. Let's say I pass a string argument up here. I can capture it up here and maybe put it into my string. And so now I'm passing a string to the greet method, and it will now greet me by name if I wish. Now, you may have noticed that there's a self argument up there in greet, and we're going to have to talk about that in the next video. For now, just set it aside. Understand that that self will always be there, and it's going to be kind of like this extra argument hanging out, and we'll reveal its identity shortly. But that any other argument that we might be passing or intending to pass to the method would be defined up here in the definition as a variable, just like any other function. In fact, you can think of a method as just being a function. It's just a function that is part of a class. That's really the definition of a method. A function that is part of a class. And we can also add and performs type-specific operations. So any method that belongs to a class is really designed to work with that object type. So string.upper, there's no int.upper, there's no list.upper. That's because it doesn't really make sense for an int upper or a list upper. So we have specific methods that are specific to this particular class. In this case, again, we're really just talking theoretically with a sample program here, but that's the idea of a method.